Okay, so we've spent some time learning about polynomials. Now we're going to talk about how do we divide polynomials so we can eventually get to a point where we can take a polynomial and break it down into its factors or roots or zeros, okay? But in order to do that, we need to know how do we divide them. So just like when we learn how to go one direction, we have to learn how to go back the other way. So before we talk about dividing polynomials, let's take a real quick step back and remind ourselves how we multiply polynomials. So let's say I had 3x plus 2 and I wanted to multiply by x squared plus 3x plus 4. Now if you want to, you can do just, distribution, the 3 to all the terms and then the 2 to all the terms. Or if you want to, you can use this area model and say 3x and 2x squared, 3x, 4. Again, either method is perfectly fine. You do whatever makes the most sense to you. So I'm going to say 3x times x squared gives me 3x cubed. 2 times x squared is going to be 2x squared. 3x times 3x is going to give me 9x squared. 2 times 3x will be 6x. 2 times 4 is 8. And, oh, hang on, wrong spot. 2 times 4 is 8, but that goes here. 3x times 4 is 12x. So then to write out my final product, I'm going to combine my like terms. I've got 3x cubed plus these two are like terms, so 11x squared. These two are like terms, so plus 18x, and then plus 8. So the product of multiplying these two polynomials together resulted in this cubic function of 3x cubed plus 11x squared plus 18x plus 8. So that's how we multiply. Well, if we know how to multiply, let's talk about how to go backwards. Suppose that we know x plus 1 is a factor of x cubed plus 4x squared plus 5x plus 2. What does that mean? Well, when something is a factor, that means it can divide evenly into whatever without a remainder. So that means x plus 1 divides evenly into that polynomial without a remainder. Just like if I divided 35 divided by 5, well, that's going to go evenly 7 times. There's no remainder. But if I divided 37 divided by 5, well, that would be 7 and my remainder is 2. So I'd say 7 and 2/5 would be the result. So if it's dividing without a remainder, or if we know something is a factor, then that means it has no remainder. So again, I know that x plus 1 is a factor of this polynomial. So that means I need to figure out what does x plus 1 get multiplied by up here to result in this polynomial. So again, we're going to use this area model, but we're going to go backwards. Instead of already having the top filled out, and then we have to fill out the inside, we're going to kind of use the inside pieces to help figure out what to put on the outside. So something, x times something is going to give me x cubed. Well, that's got to be x squared, okay? So now I've got x squared up here, and then this one, well, these two things multiply to give me just x squared, okay? So then I've already got one of my x squareds that appears here, okay? But I need a total of 4. So if I know I'm only going to get 1 in this box, that means the other one's got to have 3x squared here for these two boxes to combine to 4x squared. So then the question is, okay, if this is 3x squared, x times what gives me 3x squared? Well, x times 3x would give me 3x squared. So now that I've got 3x up here, I can say 3x times 1 is 3x, which is this box. So now, early on, we already took care of x cubed at the very beginning. We've already now taken care of the x squared terms here. So now let's take care of the x terms. So I've got 3x here. It's got to combine with some term here to give me 5x. If I already have 3 and I need 5, that must be a 2x. So then the question is, x times what gives me 2x? X times 2. And so then now I can figure out this last box. 1 times 2 gives me a 2. And again, this thing took care of this term right here. So now what this means is that when I took x cubed plus 4x squared plus 5x plus 2 and I divided it by x plus 1, that result was x squared plus 3x plus 2. That is the result of taking this big cubic divided by this binomial or this linear factor. My result is this quadratic polynomial x squared plus 3x plus 2. Okay? So then in question 4, they're asking, well, could you factor this any further? If so, write the completely factored polynomial below. Okay, so far we know that x cubed plus 4x squared plus 5x plus 2 is equal to x plus 1 times x squared plus 3x plus 2. Remember, this was the result of the division that we did just now, okay, by basically figuring out, okay, I know that x plus 1 goes into this term, or into this polynomial. What do I need to multiply by? So then could we just factor x squared plus 3x plus 2? Absolutely. And if you want, you can do another box, or if you want, you can just use factoring with parentheses. I need two numbers that multiply to 2 but add to 3. That's going to be positive 2 and positive 1. So now I can rewrite my polynomial. This polynomial is the same as this polynomial, but in its factored form. And if you wanted to, you could also say x plus 1 squared times x plus 2. You could also write it that way. Okay, so that's how we write it in completely factored form. So let's practice this again. I want you to, again, this is a moment where I really wish that you would pause the video, try number 5 on your own, and then hop back on here and see if how your answer compares to my answer. Okay, so again, I'm going to put x plus 3 here, and I'm going to go ahead and copy down the very first term, x cubed, right here. So if I have x cubed here, because I know that that's not going to combine with anything else to get this term. So x cubed goes here. X times x squared would have given me that x cubed. So then I can say 3 times x squared gives me 3x squared. I already have 4x squared, so that means I need another x squared. So x times what gives me x squared? Well, it's just going to be x. So then 3 times x will give me a 3x. I have a 5x up here, so that means I need a 2x to go here, because 2 plus 3 makes 5. And then what times x times something gives me 2x? That's got to be a 2. And then 3 times 2 gives me a 6. Does that match? Let's see. X cubed, we're good. 3x squared plus x squared is 4x squared. 3x plus 2x is 5x. And then 6 is not, 6 is not 2. Okay. That means, could be a couple of things. One, did we do it right? Pretty sure we're good there. Or that means that this needs to be adjusted a little bit. Like to go from 6 to 4, I would need to subtract 4 to go from 6 to 2. That means this negative 4 right here, this adjustment to take this divisor and result in the correct polynomial, that means that this is my remainder. So in other words, x cubed plus 4x squared plus 5x plus 2 divided by x plus 3 doesn't work out neatly. This works out to be x squared plus x plus 2, and then plus your remainder, so minus 4 over x plus 3. Now, if you're sitting here thinking, like, why did she write this as minus 4 over x plus 3? First of all, it's a minus because our remainder is a negative, but I wrote it over the x plus 3 just like if I wrote up here, 37 divided by 5 is 7 and 2/5, where 2 was my remainder. So I have to go ahead and write out like this polynomial divided by x plus 3 is equal to this quadratic, and this is my remainder. My remainder is negative 4. And I get my remainder by whatever number I need to adjust my box here to make whatever is in this box here match what I originally started with. Okay, so then does x plus 3 divide even into the polynomial evenly? No, it does not. Okay, there was a constant term of 6 and not 2. Of 6, not 2, when we divided. So the remainder is negative 4 over x plus 3. And actually, we'll just leave that as the remainder was negative 4. The remainder is negative 4. And x plus 3 is not a factor. Okay. So going down here, given f of x is equal to x cubed plus 4x squared plus 5x plus 2. Okay, same polynomial. Use your work above to identify the x-intercepts. Okay, so, oh, this was going back to the original polynomial we had at the beginning. So use your work to identify the x-intercepts. Well, this factored into x plus 1 squared and x plus 2. So that means my x-intercepts are -1, 0, and -2, 0. Okay. Find f of -1, show your work. All right, well, so f of -1 is just substituting a -1 plus 4, -1 squared plus 5, -1 plus 2. So -1 plus 4 minus 5 plus 2. That works out to be 0. Nice, that worked out well. What if I did f of -3? So that's going to be -3 cubed plus 4 times -3 squared plus 5 times -3 plus 2. Bigger numbers, that's okay. We can do this. -27 plus 36 minus 15 plus 2. I add all of that up together and I get -4. That number seems familiar. Like when I plugged in -1, I get 0, but when I plug in -3, I get -4. They're asking, compare these remainders to the remainders from number 3 and number 6. Make a conjecture about how evaluating a function and dividing are connected. Well, basically, if dividing gives no remainder, then the expression was a factor and represents a 0 of the polynomial. If it's not a factor, then the output is the remainder. So what does all of that mean? Well, remember, when I divided x plus 1 into my original polynomial up here, when I was trying to see if x plus 1 is a factor, I didn't get a remainder. My remainder was 0 because it was a factor. So then down here, when I divided x plus 3 into the same polynomial, my remainder was a -4. Well, the nice thing is, if I want to know what my remainder is, I can evaluate my function at each of those values of x. So f of -1 results in a 0 because -1 is a factor. F of -3 results in -4 because it's not a factor and the remainder from division is -4. So all of this ties into what we call the factor and remainder theorems. So if you need to pause this so you can jot all this down, absolutely go ahead and do that. But this is just kind of a quick recap of what we've done so far. When we are dividing, polynomials, taking a dividend, aka a polynomial, and dividing by some divisor, aka x plus 1 or x plus 3 in our case today, the result is going to be our quotient plus our remainder over our divisor. Okay, sometimes you have a remainder, sometimes you don't have a remainder. Just like when I divide over here, 37 divided by 5 is the same thing as 7 plus 2/5, or 7 2/5, okay? And I can rewrite this if I wanted to as well. 37 is equal to 5 times 7 plus 2. That's multiplying the divisor by the quotient plus the remainder. You can go back and forth either way. Our factor theorem, if x minus k divides evenly, then your remainder is equal to 0, or x minus 2 is a factor, or x equals k is a 0, k comma 0 is the x-intercept, or you can say f of k equals 0. In the remainder theorem, if you divide f of x, aka some polynomial, by x minus k, if that results in a remainder r, then f of k is also equal to r. So that's a quick recap of the factor and remainder theorems. I will have the Check Your Understanding posted on Canvas as well for you to check your work. So if you have any questions, please let me know.